Hello everyone, welcome to the channel Physics Fun. So in this channel, in this video, we are going to discuss the IOQP 2022 subjective first question. Right, so this is a very good question which covers almost all the concepts of SHM, and we are going to discuss complete solution. I'm going to also find out answers of all the parts, right? So please stay till the end of this video. You are going to learn many new things in this, and this is a very good question for JEE Advanced 2022 exam. Similar question with slight twist, same question also can come in JEE Advanced 2022. So let us start. First, we will read the question. So there's the problem statement. The question is that the block of mass 0.1 kg, it is attached to the spring. You can see one end is fixed to the wall with the spring constant given 50. It slides on the rough surface, assuming that both the coefficient of frictions are same, which is mu k mu s 0.25. The block is initially displaced to x naught equal to 0.1 centimeter, 0.1 meter. So from here, this is natural length, it is displaced and released. Okay, so now you have to neglect air resistance. G value we have to take as 10. And then this is 3 mark question. There are 4 parts to this. So first is how many times will the block crosses the natural length position before coming to rest permanently? Determine the total distance. So these two parts we are going to solve. Okay. So let us start now. Okay, so I have also pasted the question here. It will be difficult for you to read this right now, but just for reference, if you forget something, you can just quickly go through it. Right. So let us see. Fine. So that's the diagram. Let us start marking the values. So this distance is 10 centimeter, right? And this is natural length position. So this position is natural length. Let us see when the block is going from here to here in this direction, then what all forces are acting. So let us draw the diagram at some intermediate position. Spring forces acting like this. Block is moving in this direction. So friction will act like this, which is mu mg. Since static and kinetic friction, both coefficient values are given same. So kx is equal, kx and mu mg are acting like this, right? And then this is natural length position, right? Natural length is not mean position because friction is also active, but friction is a constant force. So first, now I'm going to find out the mean position, right? So finding mean position. How do we find mean position? Mean position is the position where net force is equal to 0. So net force equal to 0 means it should be kx is equal to mu mg. So x is equal to mu mg by k. So here mu is how much? Mu is 0.25 and m is 0.1. G is 10 divided by k is 50. So I'm going to get x as 5 millimeter. And this is 0.5 centimeter. So from here, I'm going to now mark this in this diagram. So from here, now around this distance, this is 0.5 centimeter. This is the mean position. Okay, when block is moving in this direction. See, here we have to be very careful because when block moves in this direction, that time mean position will change, right? Okay, so this is the mean position when it is moving in this direction. And when block is returning back like this, then friction will act in this direction. A spring force will act in this direction. Mean position will shift here, right? The distance will be same. We'll be discussing that later. Right now, I'm going to find out another very important thing, that since friction is present in this, so friction is what friction is going to do? Friction is going to take away certain amount of energy in every oscillation. Friction, kinetic friction is acting, kinetic friction does negative work on the system, right? So if this is the system, kinetic friction is doing negative work, and this is, let us say, right extreme. If this is right extreme and this is left extreme, then from natural length, if this distance is 10, this distance will not be 10. right? How much is this distance? Now I'm going to find out that. So let us say this distance is x1. So I'm going to now apply, very carefully you have to understand, I'm going to now apply work energy theorem between this point and this point, right? What will be the work done by friction? Friction force into displacement. Friction is a constant force. So it is now minus mu mg. Why? Because work done by friction is negative. It is x naught. This 10 initial elongation I'm calling as x naught plus x1. This is equal to what? So work done by friction is equal to change in mechanical energy. What's the mechanical energy? This is the extreme position. So here velocity is 0. This is left extreme. Here also velocity is 0. So kinetic energy is 0. Only potential energy. What's the final potential energy? Half k x1 square. Initial potential energy is half k x naught square, right? This is x naught, which is 10 centimeter. This is x1. Now here see, minus mu mg, k by 2 if I take common, then x naught plus x1 will cancel from here. So you will get x naught minus x1. Difference between the x naught and x1, right? So if I multiply minus by minus both sides, so you're going to get then x naught minus x1 is equal to 2 mu mg by k. Mu mg by k we have already calculated, which was 0.5 centimeter. So this is 1 centimeter. This is the most important thing. Once we have calculated this, after that we are almost done with this question, right? Almost. You can pause this video here. You can try again. After knowing this, you can try remaining parts. You will be able to solve it. Okay, fine. So what does this mean? This means that if this is 10, this is going to be 9. Right? So when it is coming from here to here, if this is 10, this is going to be 9. When it is going back, if this is 9, this is going to be 8. Right? The difference. That difference is going to see the difference. It is independent of the initial position. Difference is going to be 1 centimeter in one complete, the half of the oscillation. Fine. Very, very important thing. Okay, so now knowing this, we are going to find out the first and second part. Okay, so for the first part, I am going to now draw a table so that you understand very, very easily. So this is a natural length. And let us say this is right hand side of natural length, this side, and this is left hand side of natural length. I'm going to write the distances, right? So that you can count the distances and you can also find out how many times it is going to cross this. So here I'm going to write the number of times. Right, so very simple process. Now see, let us start counting. So this is the starting position. From here, from natural length, how much distance it travels? Of course, 10 centimeters. So I'm going to write 10 here. Then left side to the natural length, see where I'm pointing. How much? 9. Just now we have found. So it's 9. Okay. Now it is still on the left hand side. It has come here. And again, it travels 9. So it travels 9 here. But now when it goes here, it travels only 8. Why? Because every time the difference is 1. That's the most important thing. Now in this process, here it has crossed once, here twice. So I'm writing cumulative value here. Okay. Not the, so when it goes like this, crosses once, again goes like this, crosses once. So it starts from 10, goes to 9, then goes to 8, right? Then 8 here, 7, 6, right? And then 6 here, 5, 4, and so on, right? So let us see. Now you can complete this table by yourself also. So up to here, 10, right? 9, then 9, I've written 9 once more, and then 8. So again 8, right? Right hand side only. Again 8. So once 8, then this side how much? 7. Then again this side how much? 7. And then here 6. And this side again 6. Here, then 5 and 5. And likewise, we can continue. And finally, what's going to happen? Finally, on right hand side, when the value is, sorry, when the right hand side, when the value is 2, so it goes 2 here, goes 1 here, right? And that's the point. When it goes 1 here, it goes to 1 here, and then at natural length only it stops. So finally, this is 2 here, one here and one here. So up to this point, if you count, then totally 9 times it will cross. Right? So the answer of first one is 9 times it is going to cross. Now the total distance. So for total distance, you can add this 10, 9, 9, 8. If you add all this, the total distance is going to be 1 meter. Right? So now there is another way you can find out the total distance. How do I find the total distance? Now from here we know that it is going to stop only at natural length. So if it is going to stop only at natural length, and if you have to find the total distance, we can then apply work energy theorem directly between starting and final point. So if I apply work energy, and if total distance is x, then work done by friction will be minus mu mgx, and this is going to be equal to minus half k x naught square. Here x naught is what? 10 centimeter. X is the total distance. You can substitute the values. You're going to see that from here also x naught will come out to be 1 meter only. Fine. So I hope this is clear till now. Let us now go to the remaining parts also. So here the remaining part is we are dividing this complete oscillation into 4 times. So let us copy this also here. And then we will start marking. Okay, fine. So it's already copied here. Yes. So let us see what's T1. T1 is the time taken for the block to move from fully, so that means is right extreme, to unstirred, that means it is natural length. So let us mark here. Or before that, I'm going to mark the mean position also. So this is the mean position when it is moving this side, and when it is moving this side, then the mean position is here. And this distance between natural length and mean position we have calculated, which is 0.5, and here also it's 0.5 centimeter. So here most important thing is that even though friction is present, friction is a constant force, right? Amplitude keeps reducing, but if you see the time period of one oscillation, it is still 2 pi root over m by k, right? Because constant forces will change only mean position. They are not going to change the time period of oscillation. Very, very important point. Fine. So let us see. I'm going to now mark the timings. So T1 is the time for the block to move from full position to unstirred. So this is, see, this is T1 time. This time is T1. Right? This distance was 10 initially. I'm marking this as 10. And this distance was 9. We calculated this as 9. And T2 is the time taken for the block to move from this position to fully compressed. So that means this time is T2. Correct. T3 is the time taken for the block to move from fully compressed, that means thus, to the unstirred, that means natural length. So the distance wise T2 and T3 are same. So this is T3. Right. T4 is the time taken for the block to move from natural length to fully. So here now, see, T4 is different, right? Because see, 10, 9, 9, 8, because every time it reduces by 1. So this is then T4, and if I have to mark this distance is only 8 centimeter. Very, very important. Okay. So we have to then here mark which is more, which is less. So T1 and T2, correct? I'm writing T1 here. Understand this again. I'm writing the values. So what's T1 here? See, this is 10, this is 9. These are two extreme positions, and this is the mean position when it is traveling like this. So what's the amplitude here? The amplitude is 10 plus 9, 19 by 2, 9.5. So T1 is, what time is T1? From extreme to mean position, which is going to be T by 4. What is T here? T is 2 pi root over m by k. Right? And plus, let us say T prime. What is the T prime? T prime is the time. See, this is 1/4 of the oscillation. Mean position, extreme 1/4 of the oscillation. But T1 is this, right? T prime is the time to cover this extra 0.5 centimeter. Fine, I'm calling that a T prime. T2, what's T2? Try to think by yourself, what's T2? T2 is the from natural length to this, right? So T2 is less than T by 4 because from here to this point is T by 4. So it's less than T by 4. By what amount? Same T by 4. sorry, same T prime. Correct? Let us see T3. Okay. So here again, very, very careful. When it is moving this way, mean position has shifted. Even though T2 and T3 corresponds to same distance, but time will be different, right? Because here mean position is this, and this is T double prime, T by 4, because now this is 1/4 of the oscillation, because here mean position is shifted. So this is 1/4 of the oscillation and then 0.5 distance, right? But now here, since amplitude has changed, the time traveled in this 0.5 distance and this 0.5 distance will be different. So I'm calling this as plus T double prime. Okay. T4. What's T4? T4 is from here to the extreme position, which is now what? T by 4 minus T double prime. Okay. So you start marking T1, T2, which is more. Of course, T1 is more. You can see T2, T3, which is more. Of course, T3 is more. T3 is more. See. And then T1, T3, T1 and T3. Okay. So T1 and T3. Now we have to check T prime or T prime, T double prime, which is more, which is less. So for this, what we are going to see the distance traveled in T prime and T double prime, both are 0.5. But here amplitude is different. In T1, amplitude was, T1 corresponds to the 9.5 amplitude, and T3 corresponds to how much? See, 9 and 8, 8.5 amplitude, right? 8.5. So I will draw a very simple diagram, and then you will understand. Suppose this is one, and this is another, right? So I'm just drawing a diagram which relates UCM and SHM. So two lines, because, and then this distance is only 0.5. So bigger circle is for bigger diameter, bigger amplitude, sorry. Smaller circle is for smaller amplitude. And then you can see that theta here is going to be less, right? Here theta is more. Or we can do this again. So from here, see, this is the theta, right? And it is the theta. So for bigger amplitude, see, this theta is smaller. So time will be smaller. So T prime is less than T double prime. Fine. So if T prime is less than T double prime, then that means T3 is greater than T1. Very, very important. D1, D2. Now D1, D2 are the distances traveled in T1, T2, T3, and T4 time. So D1 and D2, what's T1? I will write the values of D1 and D2 here. Let us see. D1 is the distance traveled in T1 time, which is of course 10, right? So D1 is 10. D2 in T2 time, which is 9. D3 in T3 time, which is also 9. See, in T3, this distance also 9. D4 in T4, which is how much? 8. Right? Now we can mark D1. See, D4 is this, right? Which is 8. We have discussed this before. So D1 is greater than D2. D2 and D4, which is more, of course, D2 is more. T1 and T2 are the time periods which are equal, right? 2 pi root over m by k. So that is the whole point. Time period of oscillation is same. Friction being a constant force, amplitude is reducing, right? So I hope you understood. Now let us see the last part also for this. Now the last part is that qualitatively we have to plot the displacement x from the unstressed position versus time. So it's now very simple. We know that it's SHM only, just that amplitude is reducing. So this is time and this is x, right? So from this line corresponds to natural length. From here, first distance is 10, right? X is starting from extreme position, so it is going to be cos curve. So this is 10, but it goes only up to here, right? This is 9. Remember, by 1 centimeter reduces from one side to one side of natural length. So now when it is going up, it is again going to reduce by 1 centimeter. So it's going to be 8 only. So this is 8 centimeter. Now again, when it is coming down, it is going to reduce by 1. So it is just 7. And when it is going up, it becomes 6. So this is 6 centimeter. And now you know it repeats like this. So if you have studied the damping oscillations, where damping force is proportional to the velocity, F equal to Stokes law, that time you got something similar graph, right? It's a different graph. Mathematically, it's a different graph because there the amplitude reduces by exponentially. It is not reducing exponentially. So this is the x versus t graph, right? So these are the answers of all the questions. Like as I promised, we have found the answer of each and every part, right? So if you have liked this analysis, then you can subscribe to the channel and you can like this video, right? If you have any doubt, you can comment. Definitely I will try to answer that. And if you want me to solve some question, any question of Pathfinder or Irodov, you can just write a message in comment section. I will definitely take up that in next video. Okay, so thank you very much. Thanks for watching. Please subscribe to this and share this channel too with your friends also. Thank you very much.